à le faire,
Hi.
s'arracher l'un de l'autre,
I think
jamais été si
the
qu'il constituait une unité.
I shot some video as an introduction to this this video, which I have subsequently lost. So the object of the exercise is to go back over what I said. Unfortunately, the work that has been done, I can't show you this in the before state because I haven't got any more video of it. Okay, the object of the exercise was to make a lap to be able to lap my granite surface plate. But this is a cast iron surface plate that I got out of the skip, a dumpster for American friends, which I had to resurface in a mill because it had been used as a machine base and was extremely marked and pitted, and which I had to make, which I made. I didn't have to make. I made a fly cutter that would cover the whole of the surface to be able to cut it in one fell swoop, which seemed to me to be a lot better way of going about it than going backwards and forwards and introducing error and out of flat into it. So this ridiculously long, solid fly cutter will cover the entire width without having to make several passes to complete the whole surface. I made it like this so that I can run it on aluminium, for example, and it will be balanced. It won't, because it would have been quite heavy otherwise on one side, and it worked extremely well. I skimmed the surface plate. I found out some quite interesting things about tooling, and that'll come up in the next bit of the video. I skimmed it and scraped it, which was my first ever attempt at scraping. So my chicken scratching and scratches left in the surface all actually sort of worked for me because it came out very flat with very few hollows in it, and it took the grinding paste very nicely. So here's some video I shot about actually resurfacing this plate. I had to make handles for it, various boring things like that don't really matter. But this is, as I said, an introduction into my regrinding, my lapping full stop, my surface plate. So, let's get on with it. Well, this is the first pass with the extra long fly cutter that I made specifically for this job. You can't really see much of the state of the surface, I don't think, but this surface plate had led a very, very rough life. It had been used as a base for a machine and had all sorts of really serious dinks and divots and holes in it. And I think even after the first skim, which is a fairly hefty one, well, I'm going to have to do a couple of goes over it, I'm pretty sure. Second pass, 0.5 millimeter depth of cut, and it's running at 40 revolutions a minute, which is about it's about 40 meters a minute. So, and it's cutting absolutely beautifully. It's when it gets to a point where the tool's coming round again, it's not making a mark, but just clearing everything out the way over the entire surface. So I'll have to do, I'll check it with the repeater meter and blow it up to see what the actual finish is like and go on from there. Now this is the following day, and looking closely, this is quite enlarged by the zoom. I've got surface chatter marks, and now normally I would slow it down to deal with that, but as I'm running at the slowest speed, I can't do that. So what I've done is I've made a carbide tool, a brazed carbide tool from, here it is, from an orphaned carbide insert, which means that it will be the equivalent of running at half the speed. This is 30 centimeters, 31 and some centimeters in diameter, which means that one full revolution is a meter. At 40 RPM, that's 40 meters a minute, which is a good speed for carbide and cast iron. For the same size of cut, it would have been 20 to 30 meters a second in high-speed steel. So I'm hoping that if I just take a final skim with a carbide tip tool, this will clean things up, make it run properly, make it cut nicely and smoothly. So put it in gear. Start it up, and off we go. I think I forgot to lower it. Okay, we'll go back to that again. Right, back into neutral. Whoops. Turn the tool around. Yes, I did. Trying to think about too many things at once. Right, that is in its place, and now I'm going to lower it by 1/10 of a millimeter. And it works better if it's in gear. Right, do all those things again. I don't know whether my cut is actually going to be deep enough to get through. I'll let it run a little bit farther and see how it looks from there. Right, I'll get back to you. Well, my carbide experiment didn't work at all. I got more chatter than I got from the high-speed steel bit. I tried a shaper tool just to see how it went, Here it is. It's a shear tool that didn't work very well at all. It chattered more than anything I'd tried so far. I then tried a very sharp pointed tool, which was yet another one of my shaper tools, and that made this sort of raised, very bad sort of plough mark. I then followed that up with another one of my shaper tools, which just swing it round, swing the camera around freehand if I can, and light it up. That is the tool that I have on it that, come on, focus, damn it. That is the tool that's given me the best results so far. It's very hard to see the surface finish, but so here is the area that was done with the carbide tool, the plough shear tool, the very pointed tool, and this is the last one. It's a bit light here so that you can still see some of the chatter shining through. But the last one, the last ring here, I just lowered the tool down a tiny bit and it gave me a much nicer cut. So I'm going to have to do the whole thing again with that and see how it goes from there. The shaper tool is working beautifully. It's actually taking off little tiny curly chips and it's leaving a very nice finish behind it. So I'll just let it run. So, I said so again. This is the results of my first ever attempt at scraping. I've scraped in the plate that I found in the skip. I skimmed on the mill, and I'm about to roll it with diamond flour. This is not the most fine stuff. It's 45 to 53 microns, so it's relatively coarse, and this is what they were using on the Ox tool co's. This is finer than the stuff that they were using on the Ox tool co's surface plate regrind. Before I actually start, I'm going to note the low areas. I think it's over here, but I'm going to check it with the repeatometer to make sure that I know where I'm going. This is all very much suck it and see. So off we go. Before putting the diamond flour onto the lap, I've been over the surface plate with the repeatometer to just have an idea about where things are low. Everything in this part is within a micron. Everything that's in there is a distinct dip over here, which I think corresponds with a right-handed person working. And at the very edge it comes up, so we've got a hollow here. This is going to be interesting to see how the surface looks as I move the lap around. This is the moment of truth. I'm going to put the diamond flour onto the surface of the lab, roll it in with my roller made out of ball bearings, so that it's ground into the surface, and we'll go on from there. Well, I've made a first try at resurfacing the plate. I'm not sure where how to go on from here. It's obviously not completely level. The hollow here, I can still feel it because where I've been over, it feels rougher here. There are a couple of lines that I hadn't seen before. Over this side where it was the smoothest, this whole area is evenly rough. It's difficult to describe, but I'm going to dust it off and reload the lap, I think. I'm not sure what I'm doing, but it looks okay to me. Okay. The 2 goes over with the lap. I'm down to about 2 microns everywhere. I'm going to give it another go, I think. 2 microns as to being the most. So I'm really very pleased. Much easier than I thought it would be. I've used 10 carats of flour, and I'm going to give it another go to see whether I can just eliminate the last 2. Everything looks as though it's more or less, the very edges haven't come up, which is normal. The thing that's important is what's happening in the middle. So, very pleased so far. Okay, I've spread some, you probably can't see it, some diamond dust on here. And I'm going to roll it to brush it into the surface for the last going over. And in fact, the bearings, the difference in size in the bearings shows up here. There are only 2 of them that are crushing it into the surface, which is okay, it just takes longer. There are more now showing up on here. That's better. I didn't cut grooves in the lap because I wasn't sure whether it was going to be a good idea or not. They say that from what I've read, it works faster if there are grooves in it, which I thought was not necessarily a good idea for a novice like me. But there are the holes as well, which I wasn't sure about either, but that doesn't seem to do anything. I can't see any marks or traces on the surface plate anywhere where it's been left out. So, let's go on from there. Okay, well, I ran out of battery just when I was getting into it. I've got a fairly even quantity of granite dust everywhere. Found that if I sweep it up by hand with a small room, then that works better than getting it wet. Keeping it dry as long as possible seems to be the answer. I'm going to take the dust off and give it yet another go, and then clean it and remeasure it. Now, I've been over it a third time, to the point where it just slides on the dust. I'm pretty pleased with that, the smoothness. Now, so clean it up and test it again. Okay, I've dusted it off, cleaned it off, and I'm getting 2 microns over the whole of the surface, which is really quite good for something that is this big. I'm pretty pleased with it. It's not perfect, but I think this is going to be where it stays, at least for the time being. And when the stone is rather cold at the moment, so it may be that it'll bow slightly on warming up, which means that I'm not going to overdo it, but I'm going to just give it until next summer, and hopefully be able to use an autocollimator on it during the up and coming course with Richard King. So there we are. Very pleased, very good result. I'd just like to say a few things in conclusion about the lapping this granite surface plate. After the Richard King scraping course at Andrew Mawson's workshop, Graham Stabler, Duncan O'Brien and myself took some measurements using an autocollimator, which was very interesting because it confirmed a few things. This is the graph, which I shall put up as a separate photo. It shows that this area is very flat. There's very little difference in this area. So this confirms what I had got from my readings with the repeater meter, and that shows me where I can, I've got a good point to start from when using the repeater meter to check things out. The other thing which was very interesting was that we only had time to do the diagonals. It was very cold, the end of a week's course, and it was really great to be able to do just the diagonals. But the interesting thing about it was that Duncan calculated that in the diagonals there was a drop of 13 microns over 1 meter 30. Which is quite sort of, which is not much. It's from fraction over half a thou. Under half a thou over 1 meter 30 in length, which means it comes out as a B-class plate, which is fine by me. And I shall just wait till the weather warms up to. I shall wait till the weather warms up to do a final lap to see if I can get it in just that little bit further. So there's also an interesting series coming up by Robin rubber ends about lapping a surface plate and about measuring the aforementioned. So with that, I think I can conclude for the time being this video on the regrind of the surface plate.